the nature of science. When we talk about what science is, we need to first of all understand how science works. And we refer to these concepts that scientists have come up with as the nature of science. And we use these concepts to kind of explain how ideas are created and how they apply to the natural world. The first concept that we're going to talk about is that the natural world is understandable. A lot of the things that happen in our world occur in a consistent pattern. Now, when we talk about things like the principles of motion and gravity, we can actually apply those to modern day creations and inventions, as seen on the next slide. In the left-hand corner is a picture of Sir Isaac Newton. I know what you're thinking. Great hair. Actually, that was the style back then. Sir Isaac Newton came up with a couple of very important ideas that still can be applied to today's science. He came up with the laws of motion, which you'll learn in 8th grade, along with the idea of gravity. Now, taking his ideas of motion and how it works, along with how gravity works, we can take those principles from this guy who's been dead forever, and we can apply them to modern day inventions such as a kite. And I know the kite seems very simple, but to get the kite into the air to fly, we had to know how forces act upon it and how gravity would act upon it and how we can get over that gravity to make that object fly. The same principles apply when we talk about the invention of sailboats or rocket ships. And the last picture on the slide is sports. If you play soccer or football or basketball, the way you hit or throw or kick the ball can have a predictable outcome. We know what's going to happen if you kick it a certain way because of these laws of motion that Newton came up with so very long ago. So ideas that we've had, these ideas have lasted through time and can be applied to modern day. These are patterns that we can see that happen over and over in everything that's around us. The next concept is that science is based on evidence. We don't just come up with ideas and when somebody says, well, why is it that way? The answer is never because I said so. We actually like to have evidence to support what our ideas are. And in our science world, we have two types of evidence. We have observational and we have experimental evidence. Observational evidence comes from seeing, smelling, tasting, hearing, touching. These are what we're going to use our 5 senses for. Experimental evidence is something that you're going to get from actually performing an experiment and making measurements. We're going to look at these types of evidence later on. Our next concept is that science is a blend of logic and imagination, and I'm going to really stress the imagination part here. Like SpongeBob said, imagination. When we talk about theories or even inventions that have been created over the years, it always started as somebody's imagination. They asked themselves, what if? On the left here we have Thomas Edison, and he's holding his light bulb. He had an idea. He's like, what if I take this glass and these little pieces of metal and I create something out of them and run some electricity through them? I wonder if I can create something that will light up houses. And after many, many, many trials, he succeeded, and now we have light bulbs to light our life. The other one, probably a little closer to your middle school heart, is our first gaming system. Who in the world thought if I throw all this stuff together and throw a little computer stuff in there and plug in this game cartridge that somebody else created somewhere else, that I could actually sit and entertain myself for hours and hours playing a game? It started as somebody's imagination, and then we took ideas that we knew how things had to work, and we mixed those two together, and we have the world that you see around us. The next concept is that scientific ideas are durable, which means they last. However, as we notice new things, as we collect new evidence, sometimes we have to go back and we need to rethink the way we thought how things worked. An example from our life science class is they used to have different kingdom names. They thought different ways, and we're going to talk about those and how they changed as new evidence was found. The example that I've put on this slide, however, is about what was the center of the universe. From about ancient times up until late 16th century, they thought that the Earth was the center of the universe, and that everything else in the solar system, including the sun, revolved around the Earth. And then this gentleman named Copernicus stepped forward, and he came up with this theory that, no, I don't think the Earth is the center of the solar system. I think it might be the sun. Well, back then, he didn't get a lot of support. Years later, Galileo supported Copernicus's idea, and he was even put on house arrest. But we know today that both of them were correct, that the sun is the center of our solar system, not the Earth. Science is also a complex social endeavor, and I know that's a big fancy way of saying you don't do it alone, by yourself. Those are crazy scientists. They go lock themselves in the basement. They want to take over the world with their inventions. However, science, good science that works, is a social endeavor, and you have all sorts of people coming together to get a job done. One example that I put in these pictures would be an example of forensic scientists. You have scientists that actually go to the crime scene, they collect the evidence. Then there are other scientists that work within a lab to analyze the evidence and to see what they can find from it. And even within that lab, each scientist has a specialty. You have someone who tests the DNA in blood stains. You have someone else who will look at the size and type of footprints or tire marks. Lots and lots of different people working together to get a job done. The final concept in today's notes are that scientists need to try to remain objective. Sometimes a person's nationality, their gender, how old they are, how they were raised can sometimes affect how he or she will look at ideas and observations that they make. However, sometimes we need to step back and say, maybe I'm not seeing that whole picture. This is also when it can become a social endeavor, when scientists ask their peers to review their work to make sure they haven't missed anything. Remaining objective means that you are able to see all sides of something. An example that I've put below would be primatology. That's the study of primates. When the study of primates first started, it was mostly male scientists, and they studied things like the male gorilla's role or the male chimpanzee's role in their little society or their group. However, when more scientists looked at that, they realized that it wasn't all about the male, that the females and even some of the offspring, children, had a role to play. And some female scientists that I've put pictures of, Diane Fossey on the left, who worked with the mountain gorillas, and Jane Goodall, who worked with chimpanzees, her picture is on the right, when they entered the field, they realized that female behavior was also important, and they had something to contribute to this field. And it made the male scientists go back and go, hey, we missed that. So it makes them rethink and relook at the own work that they have completed. Now, with these concepts we've discussed on this note taker, if we apply these concepts and we understand how science works, then we can truly talk about what science is. This year, you're going to be learning about life science, which is going to be all about life. Where we came from, what we're made of, how we function. Not just how we function as an individual, but also how we work together in an overall group.